Good morning, student of St. John's 12th standard students. In this class we are going to see the last problem of this chapter number 9, integration. And for the past class we are seeing how to find the volume of certain solid of revolution using integration. And here also the similar type of problem is given. A watermelon has an ellipsoid shape. A watermelon has an ellipsoid shape which can be obtained by revolving an ellipse with major axis 20 cm and minor axis 10 cm about its major axis. Find its volume using integration. So the question is, a watermelon has an ellipsoid shape and the measurements are given. Major axis is 20 cm, minor axis 10 cm. So with this concept, first we will draw an ellipse now. You just imagine that this is y-axis and x-axis, and ellipse is drawn here. So you take this as the center of the ellipse, and this is x-axis and this is y-axis. According to the given measurement, major axis is 20 cm. So I am going to write this as 10 cm and this is 10 cm with center at the origin. So since this is origin, this 20 cm is divided into equal parts, 10 cm and 10 cm. Similarly, minor axis length is 10 cm. So I am going to write this as 5 cm and this is another 5 cm. So if I want to plot this point will be minus 10, 0. You know how it is because it is present to the left of x-axis. So the point name is minus 10, 0. And the coordinate of this point will be plus 10, 0. Right? So this is the ellipsoidal shape. This point is minus 10, 0 because of this length is 10. Similarly, this is 10, 0 because of this length is 10 and it lies in the right side of x-axis, so positive, left side of x-axis, so negative, minus 10, 0, plus 10, 0. Now, how to find a volume using integration? So first I am going to write the equation of ellipses. So what is given in the question? And this ellipse is allowed to revolve about x-axis. This is x-axis. This is the upper part. If the upper part is fastly starts rotating about x-axis, a solid will be generated. That is the watermelon. So we need to find the volume of that particular solid. So what I am going to do is first write the equation of ellipse. We know very well the equation of ellipse is x square by a square plus this is a square plus y square by b square is equal to 1. So this is nothing but equation of ellipse. What is A? Length of major axis. What is B? Length of minor axis. So substituting the values from the diagram, we are going to change this equation as x square by 100. How it is 100? A value is 10. So squaring that we are getting 100. Plus y square by, again minor axis length if you see in the diagram, that is 5. So squaring that, the answer will be 25 is equal to 1. What is this actually? This is the equation of the ellipse in which we have substituted the value for a square and b square. Now can you just imagine what is the volume of the solid formula? Volume of the solid formula using integration is integral. We have two formulas. One is integral a to b pi y square dx if we know the limit for x. Suppose if we know the limit for y, then the formula becomes integral a to b pi x square dy. Either pi y square dx or pi x square dy. So here in this problem, we know the limit for x-axis because minus 10 to plus 10. Even this sum can be done using taking y as the limit also. You can do it in two ways. What we are going to do is, we are going to take the limit of x-axis. What is the limit of x-axis for this diagram? Minus 10 to plus 10. So since I am taking the limit for x-axis, what is the formula that we are going to apply? Integral a to b pi y square dx, because we know the limit for x. So we are going to use dx. Okay. Pi y square. So I am going to find out y square from this equation. That is why I have written the equation of ellipse here. From this equation, we will try and find out the value of y square. Now if you see, this implies x square, or I can write like this, y square by 25 is equal to 1 minus x square by 100. Yes or no? Y square by 25 equal to 1. Taking this term to other side, in x square by 100. Or even I can write this as y square is equal to, right, taking this 25 to the other side, cross multiplying inside the bracket, at the same time take LCM. So it becomes 100 minus x square divided by 100. Is this right? Y square is equal to 25 into 100 minus x square by 100. So cancelling 25 and 100, we will get 1 by 4. How this 1 by 4 came? Cancelling 25 and 100. Now we got the value for y square. That is why I said, what is the formula that we are going to use? Integral a to b pi y square dx. So we found out y square. Now we can boldly go for the formula. Now I am going to write the formula. Volume is equal to, or volume of the solid is equal to, that is v is equal to integral. What is the limit that we discussed from the diagram? Minus 10 to plus 10. First I will write the formula. Instead of writing the limits, first we will write the general formula. Pi integral a to b y square dx. Since we know the limit for x, we are writing dx. And we know what is y square now, so we can substitute now. V is equal to, now I am writing the limit for our problem, minus 10 to plus 10. Pi is constant, taken outside. Y square, this value can be replaced. 1 by 4, 100 minus x square into dx. So in place of y square, I have written this value. Now this 4 is also constant, which will be taken outside the integral. So volume will be equal to pi by 4. Now I am going to integrate this. Just see this, 100 into dx. What is the answer? 100x. What is the answer for integral x square dx? And the answer is x cube by 3. These are all basic formulas which we know in 11th standard itself. X square dx. What is the answer for integration? X cube by 3. Since we completed the integration, we should write the limit. The lower limit is minus 10, upper limit is plus 10. How to apply the limits, you know very well. First apply the upper limit, minus then lower limit. So b is equal to pi by 4. This bracket is open to write the value of upper limit. If I put 10 in place of x, what happens? This becomes 1000, right? 1000 minus, if I put 10 power 3, that is also 1000. So 1000 by 3. This is called upper limit. In between we should put minus symbol. Open another bracket. Here we are going to write the value of lower limit. How to write the lower limit? Put minus 10 in place of x, so that it becomes minus 1000, right? Minus 10 here, minus 1000, another minus, so plus 1000 by 3. So this is lower limit, this is upper limit. Now I am going to simplify this. That is v is equal to pi by 4 present outside into, and if I combine these two, what happens? 1000 plus 1000. So I am going to write 2000. 2000 is written here. So 2000 minus 1000 by 3, again minus 1000 by 3. Combining that and writing as 2000 by 3. Could you able to understand this? Just combining the numbers, we are writing this. Now, how to simplify this? V is equal to, taking 2000 as common. So 2000 pi by 4 into, what will remain here? 1 minus 1 by 3, right? This is equal to, cancelling this, you will get 500 pi. Nothing will be there in the denominator, but here if you simplify this, this will give you 2 by 3. So final answer is 500 into 2 becomes 1000 pi by 3. Since we are calculating volume, cubic units. So this is the final answer, 1000 pi by 3 cubic units. We have used what formula? Volume formula, pi y square dx, because we know the limit for x. So with this, we are completing chapter number 9. And yesterday I have sent you the portions for the upcoming term test. I hope everybody has noticed that. And plan your schedule. Only 6 chapters I have given. So plan your schedule accordingly. Take time to each and every chapter. Take at least 2 days revision for each and every chapter, so that you can write the term test very well. These 6 chapters are very important chapters. If you are making use of these time to thorough all the 6 chapters, I am sure even when exam is conducted, you can still score very good marks. So now we will start chapter number 10. The name of the topic is ordinary differential equations. We know already we have completed 2 chapters in differential calculus itself, right? Differential calculus and partial derivatives. Even we have studied differential calculus separately. Differential calculus and its applications. So we know what is meant by differentiation very well while we enter into this chapter. But what is the difference between those two and this? That is the question mark. So the chapter name says that we are going to study about ordinary differential equations. The name of the chapter itself gives us a clue. We are going to deal with equations which contains differentiation. So this is called differential equations. For example, suppose I am writing an equation like this, 2x plus 3y is equal to 4. Now shall I say this is an equation? The answer will be, you will be immediately saying, yes sir, this is an equation. But if I ask you a question, whether this is a differential equation, and the answer will be no. It is not a differential equation, it is just an equation. Even to be precise, even I can say this is an algebraic equation. In fact, this represents a straight line. Okay, now what is differential equation then? This is also an equation, but this is not called as a differential equation. So what is the meaning of a differential equation? Suppose I am taking one more example. 2 dy by dx plus 3y equal to 4. Suppose an equation looks like this. Now I am asking you a question, whether this is an equation. You will immediately say yes, this is an equation because equal symbol is present. So definitely this is an equation. Yes. But if I am asking you whether this is a differential equation, and you should tell yes, this is a differential equation because this equation contains differentiation. So I think you will now understand the minor difference between ordinary equation and ordinary differential equation. So this is an ordinary algebraic equation. This is called ordinary differential equation. So what is the meaning of differential equation? Differential equation is also an equation which contains differentiation. Differentiation should be there in that particular equation. Then that can be called as a differential equation. Okay. Now we are going to take one more example. 2 times, and I just rub this because every time I am writing 2. So I will write this, d square by dx square plus 3 dy by dx equal to 0. Again, we can very well say that this is an equation because it contains equal symbol. And also I can say that this is a differential equation because differentiation is present in this equation. So this is also an example for differential equation. Now, I am going to compare these 2 equations very closely. How I am going to compare means, now first term I am taking 2 dy by dx. This is present. What is the meaning of dy by dx? The meaning of dy by dx is we are differentiating y. with respect to x. That means we are calculating the rate of change of y with respect to x. How many times we have done the differentiation here? Only one time, because only dy by dx is present. You have to observe very carefully. As I said, you should spend more time in theory class rather than the problem class, because if you are strong enough in theory class, you can easily understand the problems. So spend more time. Attentively you have to listen, then only you can understand small differences. Now again I will be going here. Dy by dx, what is the meaning? Differentiation. How many times the differentiation is done here? Only one time, because dy by dx is present. Suppose I am taking second term, 3y. Is there any differentiation present here? Answer is no. Constant side, right side, 4. It is a pure constant. Is there any differentiation there? No. So only one differentiation. That is, y is differentiated with respect to x. Only one time. Now I am just coming to the last equation. Here, d square y by dx square is present. What is the meaning? Again, the meaning is we are differentiating y with respect to x. So I also said the same thing here. Same thing you are also telling here, means the difference is we are differentiating y with respect to x 2 times. Here we have done it only one time. Here the differentiation is performed 2 times. So that is the difference between this equation and this equation. So what we are going to study now is, what is an order of a differential equation? We have 2 concepts. One is called order and degree. What is the meaning of order, or how to find an order of a differential equation? For example, in this equation, differentiation is done only once. Therefore, order is 1. But if you see this differential equation, the order is 2 because differentiation is done 2 times. So how to find order? Order is nothing but the maximum number of differentiations that is performed in that equation should be taken as the order. So understand the difference. This is also a differential equation. This is also a differential equation. But here the order is 1. Here the order is 2. Now you should be able to understand how to find order. Suppose if I am taking one more term, I am just adding one more term to this equation. d cube y by dx cube minus d square y. Just only one term I am added before and change this symbol. Now this can be also called as a differential equation. But if you ask me the order of this differential equation, I should say 3. But if you see the differential equation, each and every term is containing differentiation. This is 3 times differentiation. This is 2 times differentiation. This is 1 time differentiation. But what I am telling, order is 3. So what is the meaning of order? Even if we have more number of differentiation terms, the one which is more times differentiated should be taken as the order. Hope you will understand. Even any equation is given, you should be able to say what is the order of a differential equation. So I think you will clearly know what is meant by order. The next concept that we are going to get in is degree. What we have discussed now is order. What we are going to see now is degree. Okay. Now in this, take the same equation. Now I have found out what is the order of this equation. Order is 3. How to find the degree of a particular differential equation? If you ask me that question, the answer is, where you are finding the order. Here I have found out the order. What is the power of that term? Here the power is 1. So that should be stated as the degree. Is there any confusion? Order means what? Maximum number of differentiations. Maximum number of differentiation is taken as order. What is the degree? Degree is nothing but the power of highest order derivative. This is the highest order derivative. This is not highest order derivative because 2 times differentiation. This is 3 times differentiation. So this is the highest order derivative, and the power of highest order derivative is called degree. Okay. Suppose if I am having power 5 here, then I should say degree is equal to 5. Order is equal to 3. Order is 3. Degree is the power. Power is 5. Hope you would have understood what is the meaning of degree. Suppose if I am having power 10 here, right, the power is 5, here the power is 10. Suppose this is the equation. This is the equation given, and they are asking us to find what is the order of this equation, what is the degree of this equation. If that is the question, I should say for finding order what I have to do, just go for this is 1 time differentiation, 2 time differentiation, 3 time. This is the maximum number of differentiation. So order is 3. Again I will be writing order is equal to 3. How to find degree? Now degree is where is the highest order derivative here. Only you should take the power of that. Even if this is 10, I should write degree is equal to 5 only, not 10. Hope you are understanding. This is 5, this is bigger number than this, but don't worry about that. Where you found out the order, that power should be taken as degree. Even if this is less or even if this is more, this will be the degree. Even if this is power 100, still degree is 5. Hope you will understand what I am telling. And one more example we will take before going into the exercise problems. Suppose a differential equation is like this: sine of d square y by dx square plus 4 dy by dx equal to 3. Example, if this is the equation that was given to us, then suppose they are asking us to find what is the order and what is the degree of this particular equation. What I have to say is order. See how many times differentiation is done here? Only 1 time. How many times differentiation is done here? 2 times. So I can easily write order is 2 because maximum number of differentiation done is 2. Degree, I cannot find out degree. Here I will be writing degree is not defined. Degree is not defined. Understand carefully. Why degree is not defined means this d square y by dx square is present with sine of this d square y by dx square. So we cannot say degree when the differentiation is related with trigonometric function or exponential function or transcendental function. So sine of, cos of differentiation, tan of differentiation, if it is with the differentiation is with the trigonometric function, we cannot find the degree. Degree cannot be determined. We can say only about the order. Degree is not defined. So hope you are understanding that what is the meaning of order and the degree of a differential equation. Suppose, listen, now in place of this, I will have this equation, I will write one more equation: cos of dy by dx plus 3x equal to some d square y by dx square. If this is the situation, now what is the order? First I look at here 1 time differentiation, I look at this 2 times differentiation. So maximum number of differentiation is 2. Therefore I should write order is equal to 2. Right? But if I ask the question of what is degree of this differential equation, again the answer becomes not defined because differentiation is combined with trigonometrical function. So whenever this happens, differentiation is combined with trigonometrical function or exponential function, we cannot talk of degree. So these are the things that you have to remember. And another one, suppose if a differential equation is like this, that is d square y by dx square plus 3 dy by dx equal to 0. But suppose if the power is 1 by 3. If this happens, then also if I ask what is the order, I can say the order is 2. But the degree cannot be determined from this step. What I have to do? So when we find degree, we have to make sure that the power should not contain fraction terms. The power should not be in fraction format. That is the main thing that we have to do. When the power is in fraction format, first we should convert this to a normal integer, then only we have to find the degree. How to convert this to a normal integer? Just cubing both sides. We can just eradicate this 3 and only when an integer is coming to the power, then we can discuss about the degree. So when the differentiation function is present with trigonometric and exponential function, degree cannot be defined. And also when we find degree, the power should be free from radical sign. The meaning is the power should not be of fraction type. If it is in the fraction type, first we will try to rearrange that, convert the fraction function to a normal integer function, then find out the degree. So these are all the things that we have to keep in our mind while finding order and degree. We will see it more clearly how to find order and degree through our problems to follow. So first we will enter into the first problem. Find the order and degree of this differential equation. First you just tell whether it is a differential equation. The answer is yes, because of this dy by dx. Differentiation is present. Xy equal to cot x. How many differentiation is done here? 1. So immediately I can write, because there is no other differentiation form, only one time differentiation. So I can directly write order is equal to 1, right? How to find degree? Degree is nothing but the power of, that is the power of highest order derivative. This is one differentiation. What is the power present? 1 is present. So degree is also equal to 1. Very simple. One time differentiation is done in the entire equation, therefore order is 1. The power of that is 1, so degree is 1. Suppose if 5 is present here, degree will be 5. So keep in your mind, nothing is present, so it means 1 is there, so degree is 1. We will move to the next sum. Question number 2. Again the same thing, find the order and degree of this differential equation. Definitely this is a differential equation. Now you should be in a position to tell the answer. What is the order? Just go through the equation fully and try to find out what is the order. See the first term, 2 times differentiation. Second term, 1 time differentiation. Even in the right hand side we have differentiation, 2 times differentiation. So maximum number of differentiations done in this equation is 2. So immediately we will write, by seeing the equation itself we can say order is 2. Now I am going to find what is degree of this differential equation. Degree means how to find. I have many times told you, even in the previous sum, degree is nothing but power of highest order derivative. Here the highest order derivative is 2 and the power is 2. But if you notice on the right hand side properly, sine of d square y by dx square, the differentiation is associated with trigonometric function. Many times I told you, when the differentiation is associated with the trigonometric function or transcendental function or exponential function, degree cannot be defined. So even though there is 2 present here, don't get confused, order is 2, many students will write degree is also 2. But you should look at the entire equation, and if you listen carefully in the right hand side, differentiation is associated with the sine function, therefore degree is not defined. Problem number, it is not fifth sum, this is third sum. Question number 3. Again, the question is same. I am going to write the question here. Find order and degree. Now, if you see this, when compared with the other 2 problems, this looks slightly different because the equation itself is, if you look at the right hand side, the differentiation are present in the denominator. So what we have to do in this kind of situation? First look at this. What I am doing is, y into, just try to understand or try to analyze what I am doing. dy by dx whole square plus y into answer? Nothing I did, just I have cross multiplied, that's all. So I have taken first this term and multiplying this, dy by dx into dy by dx becomes dy by dx whole square. And when I multiply this with this, the answer is dy by dx when compared with power 3, it becomes power 4. So just cross multiplying this, we are getting this. So now this looks like a normal equation. When if you compare with the other two sums, the equations are in this model. Slightly they have changed and given. So what we are doing, we are just cross multiplying this and writing in a normal format. Now I can find out what is order and what is degree. Can you write the answer by yourself for this sum? Before I write, just try to recite the answer within your mind. Order is equal to, I am just looking at the first term, one differentiation, no differentiation, therefore order is 1 because maximum only one differentiation is performed. And how to find degree now? Now I have confusion. dy by dx, order is 1 but the power is 2. Here also the order is 1, the power is 4. We have two similar terms with the different types of degrees. And in this case, we should go for the maximum value. So we should not write degree as 2, we should write degree as 4. For example, suppose if it is 12, then I will write degree is 12. Suppose if it is 14, then I will write degree is 14. So whichever is bigger, we should take that as the degree. Therefore, order is 1. Since we have, even though we are having two powers, the one which is more should be taken as the degree. Hope you will understand. We will stop up to this and we will continue the next problem in the next video. Thank you, children.